For the first minute, imagine, if you will, the cold, mud-filled dugouts of the Western Front. Soldiers shivering in rain-soaked trenches, frost forming on their blankets, and, well, every night a struggle just to stay alive. Fuel was scarce, fires were dangerous, and traditional heating methods were pretty much impossible in such confined, exposed spaces. Yet some ingenious units discovered a way to heat their shelters using steam rocks, ordinary stones transformed into portable radiators capable of radiating warmth for hours. This lost World War I technique didn't require electricity or conventional fuel. Instead, it used the basic principles of heat retention and steam generation to create a simple, effective and honestly safe source of warmth. Understanding how it worked offers practical lessons for modern backyard enthusiasts, survivalists, and anyone interested in historical engineering. The steam rock was developed to solve the problem of heating confined, fuel-scarce spaces. Soldiers faced extreme cold during winter campaigns. Traditional wood stoves or fires were often impractical. They produced smoke, consumed valuable fuel, and could, unfortunately, reveal positions to the enemy. The idea of using stones to store and release heat offered a low-risk alternative. Soldiers would heat selected rocks near a fire or furnace, then transfer them carefully into the dugout. When water was sprinkled on the hot stones, steam was generated, spreading heat and moisture throughout the shelter. This method allowed troops to maintain a livable environment without the constant need for wood or coal, and it was highly adaptable to the cramped, irregular spaces of trenches and dugouts. The brilliance of the system lay in its simplicity. Soldiers could use stones found locally, heat them in batches, and, reuse them multiple times. The method minimized the need for flammable fuel inside the shelter, reducing fire hazards while providing sustained warmth during those freezing nights. The construction relied on careful selection of stones and strategic placement within the dugout. Not every rock could serve as a steam rock. Soldiers quickly learned to select dense, igneous stones that retained heat effectively without cracking or exploding when exposed to water. Granite and basalt were ideal, while softer sedimentary stones often fractured under thermal stress. Stones were heated in a fire or over coals until they reached a glowing state, then transported using metal tongs or wrapped cloth to prevent burns. Placement inside the dugout was critical. Rocks were arranged near seating or sleeping areas, sometimes on metal grates or surrounded by protective barriers to prevent direct contact burns. Water was sprinkled carefully to create steam, which would fill the space with warm humidity, improving both comfort and air quality. Soldiers understood that the size, density and heat of the rocks directly influenced the duration and intensity of the warmth, making proper selection and handling a key skill. The steam rock system offered advantages over conventional heating methods of the era. Unlike open fires or portable stoves, steam rocks did not consume continuous fuel once heated. They were silent, smokeless, and could be reused multiple times. A batch of hot stones could warm an entire dugout for several hours with minimal intervention. The system was also portable. Soldiers could carry rocks between shelters or heat smaller quantities as needed. Moreover, the introduction of steam into the confined space had a surprising secondary benefit. Humidity prevented excessive dryness, which often caused respiratory discomfort in the cold winter months. The combination of radiant heat and gentle steam created a more habitable environment than the simple glow of coals or a small stove. These properties made the technique invaluable to units stationed in isolated or fuel-deprived areas, allowing them to maintain morale and operational readiness under extreme conditions. Modern survivalists and backyard enthusiasts can replicate the World War I steam rock method safely. To create a practical backyard version, select dense heat-retaining stones such as granite or basalt. Heat them over a campfire or grill until hot but manageable, using metal tongs or thick gloves for safety. Place the stones on a non-flammable surface or a metal grate, ensuring they are isolated from direct contact with flammable materials. Slowly sprinkle water over the stones to generate steam and radiated heat. For enclosed spaces like tents or small shelters, ensure proper ventilation to prevent condensation buildup or unsafe humidity levels. This technique offers a sustainable and low-tech heating solution that is quiet, portable, and effective. Experimenting with stone size, placement and water quantity allows enthusiasts to fine-tune heat output and steam production, teaching valuable lessons about energy retention and safety in confined spaces. The World War I steam rock remains a testament to practical ingenuity under extreme conditions. It shows that survival often depends less on advanced technology and more on understanding natural materials and physics. Soldiers turned ordinary stones into life-saving radiators, mastering heat transfer and steam generation to improve their living conditions in some of the harshest environments imaginable. Today, backyard enthusiasts and survivalists can learn from these techniques, applying the principles of heat retention, strategic placement and safe steam generation in both educational and practical contexts. If you want more insights into forgotten wartime innovations, practical survival methods and historical engineering you can replicate today, subscribe to Backyard Wisdom, share this video with fellow enthusiasts and help preserve these essential lessons for future generations.